Welcome back to class, my amazing students. In this module, we shall consider permutation. And under the lesson outline, we have understanding permutation, cyclic permutation, permutation involving indistinguishable objects, and conditional permutation. Understanding permutation. The arrangement of objects taking into account the different orders or arrangement is called permutation. The permutation of n objects taking r at a time is denoted by n permutation r. N permutation r is given as n factorial all over n minus r factorial, where n factorial is equal to n multiplied by n minus 1 multiplied by n minus 2 till you have the series of reduced number till 3 multiplied by 2 multiplied by 1. What this means is that each number of n will keep reducing. So it means n factorial is equal to n multiplied by n minus 1 factorial. Now, if n is equal to 1, then 1 factorial is the same thing as 1 multiplied by 0 factorial. In factorial notation, 0 factorial is equal to 1. The number of different arrangements of n different objects is equal to the product n multiplied by n minus 1 multiplied by n minus 2 multiplied by n minus 3 multiplied by the series of numbers as they keep reducing till you have 4 multiplied by 3 multiplied by 2 multiplied by 1. The product is written as n factorial. The tree diagram below explains the number of ways the letters A, B, and C can be arranged. Now, for group 3, you have A, B, and C. Now, it means that if you pick A, then the second group, which is number 2, you'll be left with B and C. If you pick B, you'll be left with C and A. If you pick C, you'll be left with A and B. Now, let's proceed to the first group. Now, if you have A and B, then the last letter there will be C. If you have A and C, the last letter there will be B. If you have B and C, the last letter will be A. If you have B and A, the last letter will be C. If you have C and A, the last letter will be B. If you have C and B, the last letter will be A. So it means all these are arranged in 6 different ways. The number of different arrangements of the letters A, B, and C is equivalent to 3 times 2 times 1, which means 3 factorial. So 3 factorial is the same thing as 6. So this is the other method you can use to solve that particular question. Example 1. Find the number of ways the word Kano can be arranged. Now, there are 4 different letters K, L, M, K, L, N, and O in the word. Hence, the number of permutation of the letters of the word is 4 factorial. And 4 factorial means 4 times 3 times 2 times 1, which is 24 ways from the formula. Now, the second method is using the formula approach. There are 4 different letters, and these letters are all distinct without repetition. So by applying the formula n permutation r, which is n factorial all over n minus r factorial, n represents the number of letters and r represents the number of objects selected, and it is 4. So it means we have 4 permutation 4. So that is 4 factorial over 4 minus 4 factorial. 4 factorial is the same thing as 4 times 3 times 2 times 1. 0 factorial is the same thing as 1. So if you multiply all this together, you have 24 all over 1, which means these letters can be arranged in 24 different ways. Example 2. Evaluate 7 permutation 4. B. 10 permutation 2. Solution. For the first one, 7 permutation 4 is 7 factorial over 7 minus 4 factorial, and that gives 7 factorial over 3 factorial. 7 factorial means 7 times 6 times 5 times 4 times 3 factorial. And 3 factorial down is that 3 factorial. So why did we stop at 3 factorial? Is because 3 factorial will cancel out the 3 factorial that you have at the denominator, and the final answer gives you 840. So the same thing is applicable to 10 permutation 2, where we have 10 factorial all over 10 minus 2 factorial, and that gives us 10 factorial over 8 factorial. We have 10 times 9 times 8 factorial all over 8 factorial, which gives us 10 times 9, which is 90. Cyclic permutation. Cyclic permutation is the arrangement of things about a circular object. Is the arrangement of things about a circular object. Alright? For instance, the number of permutations of n people run a circular table is by fixing one person, since a round object has no beginning and end, and permuting the remaining n minus 1 about the fixed person. The number of ways of doing this is 1 multiplied by n minus 1 ways. Example 3. In how many ways can 6 members of a board of directors of a company be seated around a circular table? Solution. The number of ways the 6 members can be seated is equal to 1 multiplied by n minus 1 factorial, where n is equal to 6. Therefore, we have 1 multiplied by 6 minus 1 factorial, and that gives us 1 multiplied by 5 factorial, which is 5 times 4 times 3 times 2 times 1. And the final answer gives us 120 ways. Permutation involving indistinguishable objects. This is a number of ways of permuting n objects, taking n at a time, with n1 objects alike, n2 objects alike, nj till nj objects alike, and that gives us n1 plus n2 plus n3 till nd, and that gives us n. N is therefore n factorial all over n1 factorial multiplied by n2 factorial multiplied by n3 factorial till we have n whatsoever given number that we have factorial. Example 4. Find the number of different permutations of the letters of the word excellence. Solution. The word excellence contains 4 E's, 2 C's, and 2 L altogether, and we have 10 letters altogether. So the total number of permutations of the letters of the word is 10 factorial divided by 4 factorial multiplied by 2 factorial multiplied by 2 factorial. 10 factorial gives us 10 times 9 times 8 times 7 times 6 times 5 times 4 factorial. 4 factorial at the numerator cancel out the 4 factorial at the denominator. Then we have 2 factorial times 2 factorial, which gives us 2 times 2. So when we multiply everything together and divide, we have 37,800. undrained. The last part is conditional permutation. This is when restrictions are placed on the order of arrangement of the objects that are to be permuted. Example 5. Find the number of ways of permuting letters of the word L such that the two L's will always be together and B, the two L's will always be apart. Solution. If the two L's must always be together, then it must be treated together. So the double L will represent a single letter. So HELL will now give us 3 factorial, which is 3 times 2 times 1, and that gives us 6 ways. So we have 6 different ways of arranging the word L if two L's are always together. The B part. Taking the two L's, the letters of the word HE can be arranged in 2 factorial ways. So any one of the two L's can occupy any of the starred position in 3 ways. Once this is accomplished, the remaining L can occupy the 2 vacant positions in 2 ways. So what does this mean? This means that when one of the L occupy any of the star position in 3 ways, that means you have 2 factorial multiplied by 3, and the remaining L can now occupy the remaining 2 vacant position in 2 ways, and that gives us 2 factorial multiplied by 3 multiplied by 2. Hence, the total number of arrangements will be 2 factorial times 3 times 2. However, the two L's have been considered as being distinguishable, and since the two L are indistinguishable, the numbers of permutations of the letters of the word L, if the two L's must be apart, will give us 2 factorial times 3 times 2 all over 2 factorial. 2 factorial cancel 2 factorial, and that gives us 3 times 2, which is 6 ways. Thank you for listening.